Okay, so the question I'm taking up is number 17. Lori, an avid golfer, gives herself a 70% chance of breaking par, which means basically playing well, if the weather is calm, good weather, but only 50% chance of breaking par on windy days. The weather forecast gives a 40% probability of winds. Whole idea being that if it's a calm day, she's going to have a 70% likelihood of doing well, but if it's not a calm day, if it's a windy day, then she only has a 50% chance of doing well. Okay, so the overall is, what is the likelihood that Lori will break par tomorrow, assuming that she plays one round of golf? In other words, she only has one try. Okay, so I'm going to take up that one. I've got some paper here. Okay, and we've got a few probabilities. What we have is a scenario where the probabilities sort of blend together or go together. In other words, they're kind of a partnership. It's dependent probability, but we have these ideas where there's two sort of circumstances. Okay, so the question asks for the probability of breaking par. I'll call it BP tomorrow. Okay, and that's going to be based on two possibilities. It really depends on how well she plays, and it depends on, of course, what the weather's like. If the weather's good, then there's a good chance. If the weather's not good, then there's a bad chance. But we have to plan for both contingencies if we're looking at breaking par. Okay, so we're going to have the probability of breaking par, given that it's windy, to go along with a windy day. Right, windy day, you have the probability of breaking par if it's windy. Okay, or probability of breaking par, given that it's a calm day or not windy. I guess we can go windy primed or W primed, times the probability of W prime, which means not windy. Maybe I'll erase the calm and I'll make it W prime, not windy or calm. Let me, a little bit ugly. Okay, so that being the case, here we have a look. Okay, and so what we have to do is take the probabilities into account. Okay, the or, of course, means we're going to add because we have this situation or this situation. If it's a windy day, not a very good chance. If it's not a windy day, good chance. So the probability of it being windy is 40%. That they tell us directly in the question. The probability of it not being windy then, assuming that it's like a success or fail, you're either windy or not windy, is going to be 0.60. So that's an important idea to get out of that. Okay, so that's one thing that has to happen on the day, windy or not windy. Okay, and 40% or 60% totals to 100%. Again, one's a complement of the other. The other one is, well, how well does she play when those conditions exist? Well, if it's windy, we know she's only got a 15% chance of breaking par, playing well, because, the wind's going to blow the ball all over the place in golfing when you shoot it. Here, it's a bit different. 60% chance of it being windy, but she also plays better, sorry, not windy, but she also plays better when it's not windy. She gives us a 70% chance of doing well when it's not windy. So there's two situations. Bad weather, bad probability. Good weather, good probability. Both of them go together as a final overall result for how well she plays on that day or tomorrow, that one round of golf. So 0.15 times 0.60, or sorry, 0.40, I think is 0.06. 5 times 0.4. Should have done this ahead of time. Yep, I should have known better. 0.06 plus, well, 0.70 times 0.60. I know that's going to be 0.4242. Okay, and we add them together, and it's going to be 0.48. So therefore, probability of breaking par is going to equal 0.48. A very small piece coming from if it's windy, and a much bigger piece coming from the fact that it is calm. Now remember, there's other things that we're not including in here. She could not break par when it's windy. She's got an 85% chance of not breaking par when it's not windy. Okay, but we haven't included that because she's not breaking par. Here, she's got a 30% chance of not breaking par when it's not that nice. Okay, but again, we don't include that because we want to know her breaking par, or playing well. So in the end, the overall probability is 48%. So this is an example, kind of like a couple of the questions that you had in your notes. I think there was one about foxes or some sort of animal and their coat color. I think it was foxes and their coat color, or whatever. Have a look at that example, and that's kind of a similar circumstance. Okay, so hopefully that's okay for you guys.